Hi everyone, let's talk about the factoring and fudging technique for solving Diophantine equations. So I could talk about an abstract and I will do that later, but let's do an example because I think that's the best way of communicating what this technique is all about. Let's say P is a fixed odd prime. What we want to do is find all xy in the integers, so x and y is an ordered pair of integers, such that x squared minus y squared is equal to p. So if you haven't seen this before, this might seem daunting, but there is a way of doing this. So what we're going to do is, first of all, we're going to use difference of squares to factor the left side. And we get x minus y times x plus y is equal to p. Now, the idea is that this over here, x minus y, is an integer a, and x plus y is an integer b, and together they multiply to p. So what we can do is that we can set x minus y is equal to a, and x plus y is equal to b, and we can then solve x and y in terms of a and b as x is equal to b plus a over 2 and y is equal to b minus a over 2. And now it's just a matter of finding all possible b's and a's. And so because p is a prime, we know that b, well, let's do ab. A and b can be equal to 1 and p. A can be equal to p and 1, so because order matters. And the solution that most people miss are -1, -p, and -p, -1. So negatives matter. So first of all, people forget that order matters, and secondly, people forget that negatives matter. So keep both in mind. Alright, now all we have to do is solve for x and y by plugging in these a and b into this and into this. So what we get are that the possible xy are p plus 1 over 2, comma, p minus 1 over 2. We can have 1 plus p over 2 and 1 minus p over 2. We can have -p minus 1 over 2, comma, -p plus 1 over 2. And we can have -1 minus p over 2, -1 plus p over 2. And these are all ordered pairs of integers because p is an odd prime. Okay, so we found the solutions, and there are 4 of them. As this number over here, this constant, gets more and more complicated, the problem gets more complicated because there are more pairs of integers that are possible. So you have to do more casework in those cases. So what's the general method? The general method is to have f1, f2 all the way through to fn, where these are factors, equal to c, where c is some constant. And then what you do is you factor c. In fact, you prime factorize c, and then you find all possible n tuples, ordered n tuples, and multiply to c, and then you solve it the way I showed before. And this won't always work. It'll definitely work if the fi are linear, but if the fi are not, then it gets more complicated. And so there is no guarantee that this is going to give you all solutions. It depends on the complexity of the fi. Now, 2 things I want to mention. First of all, it's not necessarily as easy as moving all the variables to one side and setting equal to a constant. That's because, so far I've talked about factoring, but there's also fudging. So what is fudging? I'll give you an example. If you have xy minus x minus y is equal to 1, and you want to find all ordered pairs xy that satisfy this, integers xy, then you can't factor this, but if you add 1 to both sides, you get xy minus x minus 1 plus 1 is equal to 2. And then what you get is x minus 1, y minus 1 is equal to 2. So there might be some fudging involved where you have to add a constant to the variable side. And the second thing I want to mention is that you might even have to multiply through by a constant. For example, if you have cxy minus ax minus by is equal to d, there is no way of factoring this immediately. But what you can do is that you can multiply through by c, so you get c squared xy minus cax minus cby is equal to d, and you can, cd, and you can add ab to both sides, and what you'll get is cx minus b times cy minus a is equal to ab plus cd, and this is a constant, so we're good. So just remember that in the end it's about factoring and doing casework, but fudging is sometimes necessary, either by adding a constant or multiplying through by a constant. And finally, the thing I want to mention is that the thing we did up here, notice that I didn't solve the system of equations 4 times. I solved it in general once. So solve once in general, and then just sub in A and B or whatever your variables are. So that's a pro tip for you. Thanks for watching, and I'll see you next time.